Welcome to video number one of Where Does the Water We Use Come From? I call it video number one because this one is going to focus on groundwater, and then I made a second video that focuses on surface water. So I called it source number one, groundwater, and we do get water and use water from groundwater. So here in the valley in Fresno, there's an aquifer. It is called the Fresno Sole Source Aquifer. It's a large underground system and it supplies water to many communities in the valley and to Fresno City. The city operates about 260 wells that provide water for our homes, drinking water, lots of water that we use. So we use water from aquifers. So that then leads to the question, what is an aquifer? So an aquifer is actually a geologic place or region or feature. It's not really the water, it's the area underground. It's a layer of rock material, mainly sand and kind of gravel, that has a lot of pore spaces. Remember porosity? It's got a lot of pore spaces, and water can fit in between the particles in those pore spaces. So an aquifer is these layers under the Earth's surface that have this porous or lots of pore spaces that can store water for us. So I put this here. I thought this is a good picture, like what an aquifer is not. So an aquifer is not like an underground lake. So this looks like a lake of water, right, or a pool. It's not that. An aquifer is actually sand, gravel, and clay. If you think about the soil labs we did, I think it'll maybe make sense. Clay down here at the bottom is generally impenetrable. Water cannot get through it. So you've sort of got like a cap or a seal. And then here we've got gravel and sand. If you remember gravel and sand, they can take on a lot of water. They have all these open pore spaces that can kind of hold on to water. So what happens, it rains and the rainwater can percolate through sand, move on through the gravel, but then boom, it hits this clay layer and it gets stuck. It rains again, same thing. So over millions of years of this occurring, water has basically saturated all the pore spaces in the gravel and maybe even the sand. And it's held there because it can't get past this clay layer. Now it's not unmoving. Sometimes it'll move a little bit that way, maybe move a little bit that way, depending. Sometimes down this way, there may be a spring that this groundwater dumps into or a river. So there may be less pressure that way. So maybe it moves that way a little bit. But it's not necessarily like an underground river or a lake. And the aquifer itself is the sand, the gravel, the clay. It's actually the earth part of things. The water we call groundwater. So it tells you here, an aquifer is a body of rock that is saturated with water. And that water has built up over time, and then we can access it. So again, just to recap, right, an aquifer is made up of these gravel and sand particles. They have lots of pore spaces. A word you do need to know is the water table. So as the water builds up in the aquifer, it reaches maybe a certain level, and like the top of the water in the aquifer is called the water table. So like table, flat surface, it's like the top of the water in the aquifer. So we can drill wells, which we've done, right? Fresno City, as I said before, has like 260 wells on the aquifer here. So the wells can be drilled down into the aquifer and you can pump the groundwater up, right? And then anytime it rains, that water then refills the water that has been removed. So over, what is it, on West, I guess? If you head over to Casa Corona from school, you'll see something called the ponding basin. And during the summer, maybe it's a soccer field, but during the winter when it rains, it's a pond, it's full of water. The purpose of those is to have a place to capture water and allow it to percolate down into the aquifers and refill the water we've removed. And that's called recharge. Recharge. And we need those areas because we've built so much city. We've covered a lot of the land with pavement, with roads, parking lots, buildings, and rainwater can't get through that. It can't recharge the aquifer and replace what we've taken. So we need to have these ponding basins to kind of create those areas. We also take water that we've treated and we put it on land. There's a place called Leaky Acres out in the country, and we put the water on there to let it percolate down into groundwater. So we're constantly trying to find ways to make sure we're recharging the water that we remove, because it's happened in the past, we remove water faster than it can be replenished, and that's a problem. So this is kind of a similar redundant picture maybe, but I thought it was nice. You can see the wells, right, go down. They could go down to very deep. Groundwater, it's very expensive to drill wells, so usually they'll try to drill just where they need to go to pump up the water. Sometimes it's deeper. On the water table, they've labeled it here is basically this, like these dashed lines, like the top of the water in the aquifer. Yeah, they've noted it here. Water table. And there is some extra sandy area where more water could fill up in there if there was enough recharge. So check out, I did wanted to point this out in the water resources and irrigation playlist on my YouTube channel. I added a video about aquifers, so definitely give that a look. All right, what are some issues surrounding aquifers and groundwater? This is the big one. So we remove it faster than it can be replenished. So really this happened, gosh, even in the 1930s, we were already removing it faster than it could be replenished to really kind of get that agricultural boom we've had here in the valley. But many scientists would say this groundwater is actually non-renewable because we take it out so much faster. It took maybe millions of years to build up, and we're taking it out so fast it can't be replenished in our human life. So it's called groundwater depletion, that we've removed so much water that wells are running dry. We have to dig deeper and deeper to reach those wells. And in some places, it's just too expensive to even drill a well deep enough to get there. So this has been a big problem here in the valley. Some people say it's a tragedy of the commons, to bring back that term we did with the overfishing lab with little goldfish. The idea is that everybody's built their wells, they're pumping out water, and they're thinking, well, if I don't take any water, someone else will. I'm going to take what I need, and it's pretty unregulated. So no one tells anyone to stop, and everyone just keeps on taking what they need. It's like a straw in a cup sucking out water, and before you know it, it's the resource is depleted. So I found this, it's a little interesting. It's data from Fresno, and on this left side in blue, it's the depth, how deep you have to drill to reach groundwater. And if you look, it's going from, I assume that's feet, 20 feet down to 140. So from 1930 to 2016, basically you have to dig deeper, 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 deeper into the ground to reach groundwater is what that's showing. So in 2016, you might have to drill down 140 feet to reach groundwater. Okay? And then they kind of correlated that to, on the right, population of Fresno. The population has increased. So basically there's more demand for that water along with agriculture as well. But as we've increased the demand for water, we've pumped more and more groundwater, causing the level of the water to drop. And now we have to dig deeper and deeper to reach that water. So I thought that was kind of an interesting little graphic. So I don't know if this is that exciting of a picture, but you could see if the level of the water, if it goes down, like maybe the level of the water used to be here, this well was great. But as they pumped more and more water out, the water table dropped, the level of the water dropped to here. Now the well doesn't reach it anymore. So it's called groundwater overdraft. We've removed more water than has been replenished. We've depleted the well, depleted the aquifer, I'm sorry, and wells run dry. You can see here in the valley and in California, we've had high levels of aquifer depletion. This, and I always say it wrong, it's aguala, I know I'm saying it wrong, aquifer. I'll have to put a little video about it. But that's been massively depleted. Some areas like here, they may not have had lots of groundwater to begin with. You have to have that geologic feature, those aquifers in the crust under, your state, I guess, to have groundwater. So some places maybe don't have it, but California had lots of groundwater. Here we had lots of aguala, if I'm saying it right, groundwater. They've been depleted. And it just really means water levels have dropped. so low that we can't really access that water anymore. They may even be empty. Another effect is called subsidence. Interesting. It means sinking, I guess, the easiest way to think of it. But when the aquifer is full of water, it's actually giving some stability. It's kind of keeping things up, I guess. And as you take out water, sometimes the gravel and the sand in the aquifer will start to collapse downward, and the land actually kind of sinks. And I don't know if you can see this picture very well, but it's a famous picture here in the valley anyway. And the land in 1977, when this was taken, this was the level of the land. And basically they're saying in 1955, it used to be here. So they're saying it has sunk. The level of the land has sunk that much. That's great English there. As they've taken water from the aquifer, it's not been there to give stability to the land above, and it's sinking downward. So I call that subsidence. I just thought this picture was hilarious, his pose. I had to put it in there. But you can see where the land is kind of sunk. And then another effect of groundwater overdraft or over using, and this happens maybe like Salinas, Monterey, like places near the ocean, closer to the ocean, they'll actually get salt water, like ocean water, salt water, getting into their freshwater groundwater. So what happens, if you look here, you've got a couple wells and they're pumping water. They're pumping water. Think about that when you're pooling, it's a force. So you're pooling water up into this well, they're pooling water up into this well, right? If fresh water doesn't replace that, there's all this open space or empty space. Well, then water from the sea will get pulled in. So as they start to put that force on it, there's no more fresh water to pull up, so it starts pulling this, putting a force on it. And you can actually get salt water, they call it intruding, entering your groundwater. Well, if you're irrigating your crops or using that water to drink, you don't want salt water. That's a problem. That's a problem in some more coastal areas, maybe even on the Central Coast. This was, I thought, a nice summary. It's in your textbook. The advantages of using groundwater. If you have it available, it's great for drinking, great for irrigation. It's usually, fairly clean to begin with. Here in the valley, we've had some issues with contaminated groundwater, but it's available year round. If you don't overpump, it should be renewable. You're not losing anything to evaporation because it's underground. It's usually cheap. But if we overpump, we could deplete an aquifer. You get that sinking. You get salt water coming in. It gets more expensive as you have to drill deeper. And this was something we didn't really talk about. It's more about in water pollution, but aquifers, once polluted, are incredibly difficult to clean up. So there was a plant, and of course I cannot think of the name, that made chemical fertilizers and some different chemicals here in the valley. And they buried some drums and leaked some pollutants a long time ago that got into the groundwater. And I think it's been decades now, and we still have issues with that pollution in the groundwater. All right, well, again, check out those the YouTube channel, check out the playlist, Water Resources and Irrigation, and have a great day.